Hi everybody. So this next section 5.4 has to do with conditional probability and the general multiplication rule. So we looked at sort of the basic multiplication rule in the last section. So what we'll look at is sort of a generalization or an extension of that rule. So these will be the objectives in this section. Compute conditional probabilities, and then to compute probabilities using the general multiplication rule. So let's look at objective 1. So let's look at computing conditional probabilities. The notation P of F/E is read the probability of that event F happens given that event E has already occurred. Suppose that a single six-sided die is rolled. What is the probability that the die comes up a 4? Now suppose that the die is rolled a second time, but we're told that the outcome will be an even number. What is the probability that the die comes up a 4? So here we're so in this case we know in advance the die is an even number. So the first roll is the sample space. So we have 1 in 6 chance. Now for the second roll, since we know that it's going to be an even number, it has to be 2, 4, or 6. So the probability in that case will actually be a little bit smaller. So the probability that F given E is equal to the probability of E and F divided by the probability of E, or the number of outcomes of E and F divided by the number of outcomes of E. So the probability, so this is basically, excuse me, the probability of an event F occurring given that E has already occurred, right? And it's found basically by dividing the probability of E and F by the probability of E, right? Or the number of outcomes of E and F by the number of outcomes of E. That's basically what this equation is saying. So let's look at an example. The survey was conducted by the Gallup organization in which 1,017 adult Americans were asked, which of the following statements comes close to your belief about God? You believe in God, you don't believe in God, but you do believe in a universal spirit or higher power, or you don't believe in either. The results of the survey by region of the country are given in the next slide. So here are the outcomes, right? So in this case, the country was broken down into 4 regions: East, Midwest, South, and West. And then these are the number of people in the survey that either believed in God or believed in some higher power, or that don't believe in either one, I guess. And so the question here, what is the probability that a randomly selected adult American who lives in the East believes in God? So given that the person lives in the East, right, what is the probability that they do believe in God? So that will give you, so you'll take 204, right, divided by the total number of people that live in the East, which would be about 80%. For part B, let's say we want to calculate the probability the person that lives in the East given that they believe in God. So this might seem like the same question, but it's actually a little bit different, right? So given that they live in the East, or given that they believe in God, what's the probability that they live in the East? So in this case, you'd take this number, but instead of summing this, you'd sum this way, and that would only give you 26%. So those two things might seem like the same thing, but they're not the same, right? So this is the probability that, given that they believe in God, the person lives in the East. Let's look at another example here. So in 2005, 19.1% of all murder victims were between ages 20 and 24 years old. Also, in 2005, 16.6% of all murder victims were 20 to 24-year-old males. What is the probability that a randomly selected murder victim in 2005 was male, given that the victim is 20 to 24 years old? So in this case, we want to calculate the probability that the person is male and between 20 and 24, right, given that they're already between 20 and 24. So in other words, given that the person is already between 20 and 24, what is the probability that they're going to be male? So in this case, you take the 0.166 divided by 0.191. That gives you 86.9%. So let's look at objective 2. So we can compute the probabilities using the general multiplication rule. The probability that the two events E and F both occur is given by, in this case, remember it was the probability of E times the probability of F in the last section. But in this case, they may not be mutually exclusive. So in other words, the probability of E and F is the probability of event E occurring times the probability of event F occurring, given that the occurrence of event E. So, for example, in 2005, right, 19.1% of all murder victims were between ages 20 and 24 years old. Also in 2005, 86.9% of murder victims were male, given that the victim was between 20 and 24 years old. What is the probability that a randomly selected murder victim in 2005 was a 20 to 24-year-old male? So in this case, what we want to look at is the probability that somebody is male and 20 to 24. So we'd have to take the probability that the person is between 20 and 24 times the probability that we have a male, given that the person is between 20 and 24, given that we already know that. So in this case, you'd take the 0.869 times the 0.91, right, and you get 0.166, right? I guess in this case it wouldn't really matter what order you multiply them in, but according to the rule, right, you should technically write things this way. Let's look at another example here. So let's say that you have a bag of golf balls contains 20 Titleists, 18 max flies, and 7 top flights. Use a tree diagram to answer the following questions. And we haven't. I'm not going to require that you use tree diagrams, but you might help you sort of organize the information. What is the probability that 2 randomly selected balls are Titleists? What is the probability that the first ball is a Titleist and the second is a max fly? What is the probability that the first ball is a max fly and the second is a Titleist? And what is the probability that one ball is a Titleist and the other is a max fly? And this might help you if the multiplication rule doesn't really make sense to you. This might be another way that you could sort of organize the information. So here we have sort of the various things that can happen, right? So either the first ball is one of the 3, and then the second ball is one of the 3, and the question is, can we answer the questions here, right? So in this case, what is the probability that 2 randomly selected balls are Titleists? Well, in this case, right, we have all these possible outcomes. And so if you get 2 Titleists in a row, right, that would give you the 38 divided by 119, right, or 0.13%. What is the probability that the first ball is a Titleist and the second is a max fly? So in this case, you would go here and then go here, right? That would give you 16 out of 119. What is the probability that the first ball is a max fly and the second is a Titleist? So I guess you could think of this as, you know, what is the probability that the second ball is a Titleist, given that the first ball is a max fly, right? So you could kind of use the conditional probability we're talking about here, right? So again, just go to the appropriate branch here, right, which will give you 16 out of 119 again. And then what is the probability that one ball is a Titleist and the other is a max fly? In this case, we'll have to go down 2 different branches, right? So either we have a Titleist and a max fly, or a max fly and a Titleist, right? Both of them have a probability of 16 over 19. Since these events are independent, we'd want to actually add those together. So hopefully that answers the questions to this section, but if you have problems or questions, let me know. The next section we'll look at is 5.5 on counting techniques. Right, if you have questions, as usual, let me know.